Louisville north, you will notice you go from hills of Kentucky into flat forever. My relatives all are in Chicago. I have to make that 6-hour, 7-hour drive all the time. Once you leave Kentucky, it gets pretty boring fast, right? That's all the glacier's fault. All right.
This is why, this was interesting for me when I came to Kentucky, that all the streams flowed north. Well, a lot of them flowed north. And so this is the reason.
Part of the reason, yeah. And then obviously everything's going down the Mississippi. We have some famous Ice Age deposits and Ice Age influenced areas in the bluegrass. So Big Bone Lick, which is up in northern Kentucky and Boone County, is in the bluegrass. That's a world famous site for fossils, mostly kind of during colonial days. In fact, Benjamin Franklin and Thomas Jefferson both collected and studied fossils from Big Bone Lick. They had other people collect them and bring them to them. If you go to Monticello, Jefferson's home, there's big tusks there from Big Bone Lick. I've actually read some of Benjamin Franklin's descriptions of the bones. It's pretty neat. He was way ahead of his time. He said, having elephants in Kentucky, where today those kind of elephants only live in Africa and India, suggests that maybe the climate or the temperature was different back then than it is now. That's way before anybody thought of anything, so those kind of things are cool. It also is just a little curious thing that those bones from Big Bone Lick are part of the evidence in Baron Cuvier's idea of extinction, the first guy who actually wrote that extinctions were possible. And on one of the figures he uses is bones from Big Bone Lick of an animal that didn't exist anymore that they could find. He's also got a lot of bones from Siberia. So this little corner of Kentucky ended up making a big impact in how we view life through time. And then we have the Ice Age, and we have these adjustments in the rivers, and then through to the present day, most of the sediment that's in the streams is 10,000 years or less in age. Okay, so we have these records of what's happened in Kentucky through time preserved in the rocks and in the sediment. The Palisades are kind of interesting for a couple of reasons. One, and I know part of this is the people that are going to volunteer in parks and things in the future. Most of the parks in central Kentucky, there's a whole string of them along the Palisades. The Palisades are an entrenched meander with steep sides down into these thick limestones that can hold up the cliffs. As you come around towards Frankfort in the Kentucky River, you don't have Palisades because you start to get more shaly rocks, and the slopes weather a little bit differently. They can't hold up a cliff as easy. We also have these faults that bring different rock types against each other, and that makes little small scale changes in the profiles of the cliffs and in the weathering of the slopes around those areas. This class went to Flora Cliff? Yeah, so that's right up in here. Okay? And part of your homework exercise will be using our map interface to look at the geology in this area. So, two things that influence kind of the local topography, slope, groundwater movement are fractures and faults. So the Palisades is a really good area to see some of those influences. A fracture is any break in a rock. All right, usually where there's no offset. So you see the same layer of rock and it's just broken. And it's usually broken along a line. Joint's just a different type of fracture. They often occur as conjugate sets, kind of at an orthogonal angle between each other. And then in a fault, you actually move the rock consistently up, down, or sideways along that break. So essentially a fault is a fracture which there's been big movement on through time. Lots of fractures, fewer faults. All right, but both are influencing the topography in the bluegrass region, especially along that Palisades and eastern and southern edge of the bluegrass region. And just show up some pictures. So I think this is Raven Run. If you were at Floor Cliff, you would have seen the same thing. You go down the little creeks and tributaries there, and all the rock is in these blocky shapes. That's fractures. There's two fracture sets. So there's a fracture set going that way and a fracture set going that way. The rock has that fracture in it. That makes it easier for water to get in there, percolate down through, and ultimately erode through. And so you see lots of these little right angle changes in the stream. Some of the streams actually make little right angle turns. If you look at maps, you sometimes see the streams lining up along some of the fracture patterns, or some of the tributaries lining up along fracture patterns. And then these are the faults, these are black lines where there's been larger scale offset. You can see the kind of the boundary of this Lexington limestone is right up against this fault system. And the Kentucky River kind of follows back and forth along that, which was a natural break, a natural place for the river to find weaknesses in the rocks that travel through. Horse farms and agriculture. Obviously, we've got this area that's pretty low-lying hills. That's perfect for farming, for having large areas of level land. If you go out to the hills area where you have these steeper-sided shaly hills, it's tougher to have acres of row crops. Right? So there's a direct influence on the agriculture. There's different types of plants that can grow on flatter areas than on steeper slopes. So that influences both our agricultural use and the natural plants that are there. Got a lot of phosphate in some of the rocks around here. That makes it easier growing. It's natural phosphate. In fact, if you're using fertilizers that have phosphate in most places, you're putting way more phosphate on than you need, because a lot of the rocks have natural phosphate in them. So that influences the soils a lot. Then there's Bourbon, the Bourbon area. All right, so not only do we have the calcium and the phosphate, but we have all these springs and water. And because it's calcium rich and has no iron in the water, because the rocks don't have a lot of iron in them, that's what you need for making bourbon. All right, so you can actually make bourbon where there's calcium water in other places, but obviously we have the signature area for it and the historic area for it. All right, it's also a good place to grow corn. So if you've got corn nearby and you've got springs without iron in them and a little ingenuity, you have a good drink and a signature drink for our state. We also then have rock resources, and we use rock resources all the time. As I said, most of central Kentucky is limestone. Limestone is what we use for aggregate to make cement, for gravel, construction. You'll notice that a lot of the quarries are in or near urban areas, or they're on the interstates, because you got to transport that gravel to the places you need to build, or you've got to transport the cement to where you need to build it. So we have lots of quarries and mines in the center here, where we have the Lexington limestone at the surface. Then we have fewer in the hills area and in the outer bluegrass, because there's a lot of the shalier rock and thinner limestone. They want to be in the thicker beds if they're going to quarry it. And then you have a bunch here in the Louisville area where there's some thicker limestone. So your distribution of where the resources are to use, to develop, to build is not equal across the state. You can't put a quarry in anywhere. Right? And in some areas that becomes a big issue. So Louisville, for example, really has spread out over the last 100 years. It's spread out past where the quarries are. Nobody wants a quarry in their backyard, right? That creates a big issue, right, for different land uses. So you are now moving Louisville out past where the good limestone and dolomite is for quarrying. So what do you do for resources in those areas? You can't just put one out here. It's not going to work. So there are real world issues on how we grow and how we develop and where we get our resources from. The other thing that's interesting about central Kentucky is we don't have a sand here. You need sand for cement. You need sand for asphalt. So we have to get sand from up on the river here and transport it. Right? So where you get the materials that you're going to mix to do things with is different in different parts of the state. In the bluegrass, there's a couple, historically they mined the Lexington limestone and quarried the limestone, so most of the surface quarries in this area will be in the Lexington limestone. And then there's some better limestones and dolomites down here at depth. So if you're along the Kentucky River, you can put a mine in sideways and get right into those. If you're in Lexington, you got to go down. So we will see near McConnell Springs a quarry that's down here at pretty much the same level as the quarries that are out in the Palisades going in from the side to get to that better rock. And then that's all I have on the kind of general geology background. The next thing I want to do with like the next 10 minutes is kind of just show you our website and how to use the website. I got a homework assignment on using the website. And in the future, when you're looking for rock information, geology information, topography, landscape information, and you have forgotten who I am, where I was, what we talked about here at All Today, you'll at least have this that you can always go back to and find information. So I just wanted to give a kind of quick how to use the website and what's on the website. I put it up in Chrome or Firefox here. And there'll be a homework assignment online that has a tutorial that'll go through a lot of the same thing I'm doing here and just some questions. It's just, did you do the assignment, pretty much is how the assignment's going to be. But it'll just take you through using the website and using floor cliff as an example. Okay? So this is how the website is set up. Some general information about Kentucky geology, energy resources, oil, gas, coal, water resources, a lot of information about karst and groundwater and surface waters, natural hazards like earthquakes and landslides, just data, huge amounts of data available, publications, and then online maps. We also have education resources if you know any educators, a lot of K-16 information. But we're going to go to online maps. And you get this kind of selection here. And if you click the Geologic Map Information Service, you get the geologic map of the state. Okay, and there's lots of tools. You can zoom in using typical zoom tools, or you can choose from the tool menu, zoom to. And this just gives you many different ways to get to information. So if you have a lat long, if you have a county, if you have whatever kind of information, you can zoom to it. One of the things you can also do is historic sites, natural areas, natural preserves, state and natural parks. We do natural preserves. Oops, it didn't work. Then you get a pull down lists of what we have for our lists for historic sites, natural, whatever the state has given us. All right, so you can zoom to specific areas if you know what you're looking for. We'll just do Floor Cliff as an example. Zoom to. And the map goes right to it. All right, and so then you have that. If you're working in a park or in an area, you can have the geology right there to understand what it is. Now this is just giving you a map. Then you can customize this map. You can zoom in and get different kinds of data for this map. All right, so first off, there's these different colors. These different colors are essentially telling you different rock units. If you use this little I for identity, identify, and click on. It's always good when this actually works too. It's a really good service. It will give you what that color is, what the units are. It gives you a rock description. It tells you what the units are like. It gives you links to different areas. So that's the Camp Nelson limestone. It gives you a rock description. It tells you if there's any economic issues. And then it gives you links to water data, all sorts of things in the area. Click that off. You can use this little bar here To zoom in and zoom out, I'm going to zoom out just a little bit. You can customize the map to put whatever you want. If you go to layers, there's a topographic map loaded in this. There's an aerial photo map loaded in it. There's LiDAR coverages loaded in it. There's index maps, counties, quadrangles, mileposts, all sorts of things. So I'm just going to go to the topographic and hillshade. Now you customize your map to put topography on there. If you scroll down a little bit more, you can take the geology in and out. There's the topography, there's the geology, and you can really look at how the different rock units are affecting the slope in floor cliff. Wanted to, you could pull up all the water wells, all the springs that are in the area, all the karst features that are in the area. Some other areas, there's not a lot of oil and gas development in central Kentucky, but you could pull up all the oil and gas wells, get all that information as well. At the very bottom here is the LiDAR coverage. This is the 3 to 5 foot resolution surface, and there's now LiDAR on top. So you can really customize the map to get a better understanding of the geology in your area, and that's not available in a lot of other places. So the reason we can do this is back in the 70s, Kentucky volunteered with a program with the USGS to geologically map the state at the same scale the topographic maps were done. That was over 700 maps, 700 7x10 areas. And we are one of 2 states in the nation that has that. Delaware being the other one, and Delaware is like a county in this state, right? And then when computer technology advanced, we said, let's be the first state to digitize all those. So we digitized all those maps and then made it digitally available. So there's a huge wealth of geologic information that you can get. I'm going to show you one other thing on the survey website here that can help you just for general information. If you go to Kentucky Geology, so this is general information, rocks and minerals, fossils, mapping, minerals, general geology, and I have this in the, I think on the PDF for the homework assignment as a resource. If you scroll down through here, there's something called county geology. Generalized geologic maps for land use planning. You get the state of Kentucky, and you click on a county, and you will get a compiled, simplified geology map of the county with things that relate to land use. So there's lots of pictures of the kind of agriculture, waste disposal systems, whether they use septic tanks or their sewer lines. The little red dots on here are sinkholes. So things that have to do with our land use of the geology and the geologic resources in that area. All right, thank you very much. Any questions?
How often does that get updated?
The land use maps are fixed, so they're done, unless something major came along and somebody wanted to redo that. The layers and the data layers that are on the Geologic Map Information Service, it depends on the data. So like well information gets updated all the time. Unless somebody saw a major error or something, the map data would not be as updated.